Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving a maximum minimum problem with complex numbers. So we're given that the absolute value of z is equal to 1 and we're supposed to maximize, in other words, find the maximum value of the absolute value of z plus 1. Can we do this problem? Let's give it a try. Now, since the absolute value of z is equal to 1, I'm kind of thinking of a number that could satisfy this criteria. And if you're familiar with complex numbers a little bit, you'll recognize the number that I'm about to write. If you're new to complex numbers, go ahead and check out my lecture videos. I also have another channel. If you like algebra, number theory, and trigonometry problems, go ahead and check out Cyber Math, that is cyber with an S. You can also become a member to support the channel. All right, great. So let's see how we can approach this problem with some numerical examples. Now, a complex number whose absolute value equals 1, actually there's a couple of them, but this one is well known, can be written as 1/2 plus root 3 over 2i. Now, where does this come from? Well, this comes from actually the cube roots of a well-known number. And again, if you're new to complex numbers, go ahead and check out lecture videos. If you know what I'm talking about, this should make sense to you. But this number, if you check, and if you're not sure, you should always check that. To find the absolute value, we take the real part and square it. We take the imaginary part and square it, and we add those two numbers and take the square root of the sum, which gives us 1. So yes, that's true. We have a complex number whose absolute value equals 1. Now, why did I say it's the cube root of a complex number? Well-known number, because if z cubed is equal to 1, just think about it for a minute, right? Then you basically get 3 solutions to this equation, because there are 3 complex numbers whose cube is 1. In other words, those are the cube roots of 1. Obviously, one of them is 1, which is well known. The others can be expressed in terms of trigonometry or some special angles, right? And this is one of them. But I'm not saying this is the cube root of 1, because this is the cube root of -1. But why does it work? Well, if z cubed is equal to -1, when you take the absolute value of both sides, you're going to get the absolute value of z cubed equals 1, because the distance from 0 to -1 is also 1 unit. Remember, absolute value cannot be negative, even in the complex world, right? It can be 0 if z is 0, but that's not interesting. And from here, you can basically write this as follows. And from here, you can deduce that absolute value of z is going to be 1. So we basically show that if z cubed is -1, then absolute value of z is equal to 1. Okay, but can we actually check that? Sure. You can take that number and cube it, and what you're going to realize, if you know the polar form of a complex number, this can be written as e to the power I times pi over 3. And if you cube this number, oops, I did a hocus pocus there, you're going to get the following. Cube both sides, you're going to get z cubed equals e to the power I pi, which is equivalent to -1. Great. Now, don't get me wrong, there's infinitely many ways to express -1, but e to the I pi only represents -1. And it's true because I already told you, right? Okay, great. We checked it in different ways. Now, but wait a minute. This is telling us to maximize the following. So if z is equal to that, what happens? Let's go ahead and find out. If z is equal to that number, what is the z plus 1 gonna look like, right? You're just gonna add z plus 1. So our number was 1/2 plus root 3 over 2i. You're just gonna add 1 to it. That's gonna become 3 over 2 plus root 3 over 2i. You can do this in so many ways, but probably the easiest way to do it is square the real part and square the imaginary part. You get the square root of 12 over 4, which is 3, and this gives you square root of 3. Is that the answer? There's no guarantee, right? Because they're asking us to maximize it. How can you guarantee that this is the maximum value? Or is there another way to approach it, right? So let's go ahead and look at it from another perspective, because numerical examples may help to help you see the process, but you can't really go through infinitely many examples, right? It's not going to work. So we need a more general approach. Can you think of a complex number whose absolute value equals 1, without specifying numerically like 1/2, √3/2, so on and so forth. And here's where trigonometry comes in handy. You can write z as cosine theta plus I times sine theta. And according to Euler, thanks to him, because he gave us the most beautiful equation in math, nothing can beat that. This can also be written as e to the power I theta, which we know that absolute value of that number is going to be 1. But why is that happening? If you think about it, trigonometric identity is going to give us cosine squared plus sine squared, and even if theta is complex, let me repeat, even if theta is complex, this is going to be true, it's always going to be 1. Great. So this is actually a better version of a complex number whose absolute value equals 1. It's much better than 1/2 plus √3/2i or √3/2 plus 1/2 I or any other variations, because we didn't specify the theta, right? That's a general form. Great. And obviously you can verify that here. The numerical example also satisfies the cosine sine criteria, right? Great. Now let's go ahead and see how we can use this to our advantage, right? Because our goal is to maximize z plus 1, the absolute value of that, right? So let's go ahead and plug it in. I know it's going to look weird first, but then it's going to simplify. So we're going to replace z with cosine theta plus I sine theta, and then we're just going to add 1 to it. But how do you add 1 to something in trigonometric form? Well, this is standard form, but at the same time, it's expressed trigonometrically, right? Here's what we're going to do. We're going to put these two parts together because they're both real parts, right? That's how you add complex numbers. And this imaginary part is going to be left alone. Too bad. Sorry about that. Now, here's what we're going to do next, which is, I think, amazing. I find this mind-blowing. There's quite a few problems like this one. This identity comes in so handy. You must know this, okay? And here's what it is. Cosine theta can be expressed in terms of half angles. In other words, if theta is 2 times another angle, like a double angle formula, you can write it as 2 cosine squared half of theta minus 1. This is equivalent to cosine theta if you know a little bit of trigonometry. If not, look up the double angle formula. You're going to know what I'm talking about. Plus 1, of course, the goal is to cancel out. That's why I picked this one, because there are 3 versions of this formula, but that's another story. Check out my other videos, particularly the trigonometry playlist. But wait a minute, it's not here. You have to go to Cyber Math and check out my playlist. And let me know what you think about those. Now, what are we going to do for sine theta? Something similar, double angle. It can be written as 2 sine alpha cosine alpha, remember that? But this time, you're going to have to cut the angle in half, because theta is supposed to be 2 times an angle, which is theta over 2, of course, right? And of course, the whole thing needs to be absolute valued. Great. The -1 and the 1 cancel out. This gives us the following. The absolute value of 2 cosine squared theta over 2 plus I times 2 sine theta over 2 times cosine theta over 2. And we're supposed to do what? We're supposed to maximize this. Are you serious? This is so complicated. No, not really, actually. If you do this, use a little bit of algebra. Now take a look at this and take a look at that. Do you see what I'm talking about? Do you see what I see? I hope so. They have a common factor, which is cosine theta over 2. Considering this 2 here, we can safely say that 2 cosine theta over 2 is a common factor. If I take it out, I end up with cosine theta over 2 plus I times sine theta over 2. Beautiful. Now we're going to have to absolute value the whole thing. Is absolute value a verb? Well, if you say to absolute value, it'll be a verb, okay? So we verbified it, in other words. Anyways, now, what are we going to do? We're going to separate them. And actually, this is a product of 3 things, right? So we can actually take this 2 out, because the absolute value of 2 is equal to 2. So we can just write the 2 on the outside, and then cosine theta over 2 in absolute value, and then the rest in another absolute value. And the reason why we separate all these things, because it's going to make our life easier. You don't want to make your life easier? Of course you do, right? Great. Now, take a look at this. This is 2. What about this one? We just talked about it. Remember, cosine theta plus I sine theta is a complex number whose absolute value equals 1. And guess what? If you replace this with alpha, this becomes cosine alpha plus I sine alpha. Again, the absolute value is going to be 1. So this whole thing is equal to 1, including the absolute value. Great. Multiply by 2, you get 2. So now we end up with something like this, and we're supposed to maximize this. But wait a minute. We know something, right? Well, in this case, we're going to assume that theta is real, right? Otherwise, it's going to be out of bounds. But if theta over 2 or theta is real, then cosine cannot exceed 1. In other words, this is less than or equal to 1, so this expression is less than or equal to 2, which is exactly what we were trying to maximize. Where does that come from? Sometimes you forget, right? You write too many things in math, and then at the end, like, where do we come from? Okay, that's why you need to keep good notes and always write things down, okay? Be organized. I'm not that organized, I know that, but anyways, at least be as organized as I am. So what did we find? We found that the absolute value of z plus 1 is less than or equal to 2, and we were just trying to find the maximum value of this expression, which happens to be 2 in this case. Great. Let's go ahead and take a look at an alternative, should we? Well, let's just call all of this first method. Now this is going to be the second method. And this is what was meant actually. But let me tell you, we are given that the absolute value of z is equal to 1. And what are we supposed to maximize? The absolute value of z plus 1. So here comes the triangle inequality to the, what's it called? To rescue. Yes, that's what I was trying to say. So here's how it works. Triangle inequality for complex numbers says the absolute value of z plus w, two complex numbers, is always less than or equal to the sum of the absolute values of z and w. Why is that happening? If you think about it, you'll find out. There's a proof of it which we're not going to go into, but this works. And how is that helpful? Well, if you replace w with 1, because 1 is a complex number, remember, you get the following. Absolute value of 1 is, of course, 1. We know that absolute value of z is equal to 1. It's given. So this is equal to 2, which gives us the absolute value of z plus 1 is less than or equal to 2. No sweat, right? We got the result right away. And we were trying to maximize this. So the answer will be 2 again. And let me show you one more thing. I know this has been a long video, but who cares, right? As long as you guys watch it till the end, okay? Make sure to spread the word. Now, here's what I'm going to show you. It's pretty interesting. Now, what does this represent on the complex plane? On the number line, if you talk about the difference, the absolute value of x minus y, it represents the distance between x and y. No matter whether x and y are positive or negative, it doesn't matter, but this always represents the distance. Same thing. But this is distance in 2D, right? Because complex numbers are two-dimensional, like vectors or points. So this represents the distance between z and w. And think of z and w as points, that your life is going to be easy. Don't think of them as vectors, okay? Who cares about vectors anyways? I don't like linear algebra. I don't like vectors. Sorry about that. If linear algebra is your favorite, no offense, I just don't like it. Probably because of some negative experience. I had to take an advanced linear algebra class without taking linear algebra, and the professor was not so good. Anyways, that's a different story. Let's get back to this. Now, how do I apply it to this? Well, you can always turn this into a minus sign by doing a little trick. So the absolute value of z plus 1 is the distance between z and -1 on the complex plane. So, by the way, don't forget that the absolute value of z is 1. So we have a circle, a unit circle. So our z, our number, is on this circle, right? Anywhere, doesn't matter, as long as its radius is 1. Great. Now, what are we going to do? Here's what we're trying to do. We want the distance between z, which is any point on this circle, and -1 to be maxed. So if your z is here, the distance between this and -1 is going to be here. If your z is here, the distance is going to look like this. Notice that you're getting far away, right? Uh-oh, when my number is right here, it's going to be the farthest away, right? And that's going to be exactly 2 units because this is a unit circle. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care. Remember to check out Cyber Math and aplusbi, and bye-bye.